Hello, today we're going to be teaching you how to find delta G, which is the difference in free energy between the reactants and the products. In an equation, it can tell us whether or not a chemical reaction will happen spontaneously. That's very important for a lot of reasons. To do that, we'll need to find these two different constants, delta H, which is the change in enthalpy of a reaction, and delta S, which is the change in entropy of a reaction. And we can calculate those by using a table here that lists the values for each of the molecules in our reaction.
So the general equation that we're going to be using is delta G equals delta H minus temperature times delta S. And essentially the values we're going to be plugging in here are the delta H values, which you get from subtracting the products times their coefficient from, or the other way around, subtracting this,
Yep.
The delta H of formation of this reactant from the delta H of formation of H2O. So that's 3 times 241.8 minus 842.2, and that gives you 116.8 kilojoules per mole. And then for the standard enthalpy, you're essentially going to do the same thing, except this time you have 2 reactants and 2 products. You multiply each of them by their coefficients and then subtract the products from, or you multiply each of them by their coefficients, add them up, and then subtract that for the products from that from the reactants.
Yeah, reactants minus products. Yep, and then so just to explain what these variables are, delta H is the change in enthalpy, or the change in total heat across the system when the reaction goes, and entropy, or delta S, is the change in entropy, which is just can be said most easily by the amount of disorder in the system. So in this case, it is positive, which means the system gets more, or the system gets less ordered, which is generally favorable, because that's how the universe tends to work. As if you think about, I like to think about it as if you have a desk and you have a bunch of stuff on there and you just like randomly work it there, almost never is your desk going to organize itself. It's going to be in one of the almost infinite ways it can be disordered. So there's way more ways to be disordered than there are to be ordered, which is why this is favorable, a positive enthalpy. And we've also learned that when you have a positive delta H and a positive delta S, the reaction can be favorable, but it needs to be at a high enough temperature. And so we calculated it first at 25 degrees Celsius and found that the delta G was positive, meaning it was not favorable, or would not happen spontaneously.
And with the value for the delta G, we calculated that with this equation right here, delta G equals delta H minus temperature times delta S. And to find that at 0 degrees, we just plugged in 0 for the T value.
Yep, and then that would give us the temperature when it becomes spontaneous. As you can see, we solved this equation. If you do a little bit of algebra, you can find out that T equals delta H over delta S when delta G is 0. And if you solve this for our values up here, you will get 823.69 Kelvin, which is 550.5 degrees Celsius.